Going on to the next part of our discussion on impulse and momentum, we have collisions. A collision occurs when two or more objects run into or hit each other. For example, you have the following situation. You have object M1 and object M2 moving towards each other. Eventually, they will run into and hit each other. The two objects will collide. You have collision. There are three types of collisions to speak of. You have elastic collision, inelastic collision, and perfectly inelastic collision. In an elastic collision, the kinetic energy of the system is conserved. Kinetic energy of the system is conserved, meaning initial kinetic energy is equal to final kinetic energy. In terms of the collision, kinetic energy before the collision, you have initial kinetic energy. And then right after the collision, you have final kinetic energy. So, initial kinetic energy of M1 plus initial kinetic energy of M2, that's the total initial kinetic energy before the collision. And then you have final kinetic energy of M1 and final kinetic energy of M2. That's total final kinetic energy right after the collision. Okay, so initial kinetic energy before the collision, final kinetic energy after the collision, they are equal. Kinetic energy of the system is conserved for elastic collision. However, in an inelastic collision, the kinetic energy of the system is not conserved. There is energy loss. Before the collision, initial kinetic energy. After the collision, final kinetic energy. The two are not equal. Final kinetic energy is less than the initial kinetic energy. There is energy loss. This energy loss is maximum in perfectly inelastic collision. The kinetic energy of the system is not conserved. There is energy loss such that the objects stick together after the collision. So, depending on the type of collision, the kinetic energy will either be conserved or not conserved. But regardless of the type of collision, the momentum is conserved. Initial momentum is equal to final momentum. Initial momentum is momentum right before the collision, whereas final momentum is momentum right after the collision. So, initial momentum before the collision, final momentum after the collision, momentum is conserved, initial momentum is equal to final momentum. And momentum is conserved regardless of the type of collision. It doesn't matter whether you have elastic collision or inelastic collision or perfectly inelastic collision. Initial momentum is equal to final momentum. Momentum is conserved. Whereas, kinetic energy is conserved only in elastic collision, but for inelastic and perfectly inelastic collisions, the kinetic energy is not conserved. If you want to analyze the system in terms of energy, you have to take into account the energy lost during the collision. In that regard, when you see that there is collision in the system, you're better off using conservation of momentum because momentum is conserved regardless of the type of collision that occurred. Again, initial momentum is equal to final momentum. Initial momentum is right before the collision, and final momentum is right after the collision. For a more complete picture of collisions, you might want to look into the coefficient of restitution. So some of you or all of you might want to consider that as a reading assignment for a more complete picture on collisions. And that's it for now. In the next video, we'll continue our discussion on impulse and momentum by looking at a few examples regarding collisions. So again, that's it for now. Thank you for watching.